Hello students, welcome back. Previously we went through the linear equation, through basic strategy, some trivial example, a little bit less trivial example, and some good example problem for its denominators. Now let's continue over to the problem for its denominator like this. What's the difference? Here we had only numerical denominators. Here we have x expressions down there. Will that make a significant difference in terms of strategy? Not really, as a matter of fact. So that's the basic strategy. So let's copy and paste here so that we don't forget. And then let's go ahead with some example problems. Let's say the first problem. Let's see. It's going to be better with bigger fonts because we have some fractions here. Let's put some space in between so we can read better. Okay, all right. Here's the equation, the same equation as before. And then step 1 is to remove denominators. What's the LCD? Previously we had numbers. We had this time an x expression. Will that make much difference? Not really, to tell the truth. Multiply by that very expression here. I multiply by the same expression to the left-hand side and right-hand side, so the equality will be preserved. And then what do you do? Do we break up this numerator by foiling out? No, don't do that. Parentheses is step 2. Step 1 is to remove the denominators. Don't forget the purpose of this LCD business. We multiplied by x minus 2, and the purpose is to remove the denominator. Parentheses can wait. So x minus 2 divided by x minus 2, which is just 1. So we have just 3x plus 5 on the left-hand side. Oh, excuse me. In the right-hand side, let's break up the parentheses. Negative 2 times, excuse me. Okay. I decide to take an extra step. Most students will skip this and go to the next step, but I decided to take it anyway. So after removing denominator, this and that gone, keeping everything the same, that's what we have here for now. And then let's break out the parentheses. 3x plus 5, negative 2x plus 4. Distributing negative 2, distributing negative 2 times negative 2, so we have positive 4. Okay, and then let's take the line terms together. 3x plus 2x equal to 4 minus 5. Remember, change the side, change the sign. So we have 5x equals negative 1. X is therefore negative 1 over 5. Looks like that's the answer. Did I do everything right? Yes, the answer key. Yes, everything is right. And here is Mathematicus verification. Yes, he found the solution, negative 1/5. By the way, whenever you solve an equation with some non-trivial denominators, or something even worse, make sure you plug in the answer back into the original equation and check. If you have no denominator, just polynomial equation, then that's okay. But if you have denominator, or even worse, if you have square root or even some transcendental terms like exponential log and so on and so forth, it's a good idea to plug in the answer back into the original equation. Even for linear equations or quadratic or any kind of polynomials, still it's going to be a good idea to plug those back into the original equation. But if you have denominator or square root or things like those, then it's absolute necessity as a matter of fact. We'll come back and talk about it in a little bit more detail. For now, let's focus upon the solution method. Okay, how do you do the next problem here? So what do I multiply to remove all the denominators? What's the LCD? It's not significantly different from the numerical denominators. Just use the product of the denominators, x minus 1 times x minus 2. This thing here. Multiply that thing to each term. You have to distribute to each term. And then don't even think about folding out the numerator. It's going to create a mess. Remember the purpose of all this. Step 1, we have to do the denominator. Parentheses can wait. So how do you remove this denominator, x minus 2? Well, this x minus 2 divided by x minus 2, that's gone, and what's left is 3 times x minus 1. How do you remove this x minus 1? This x minus 1 divided by x minus 1, so what's left is 1 times x minus 2. And in the right-hand side, everything is gone, you just have 7. Of course, nobody writes like that, negative 1 times like that, it's just that. That's more common expression. Okay, no more denominator. Now is the time to remove the parentheses. Let's break up parentheses by distributing by 3 and then distributing by negative 1. And then let's take the like terms together. 3x minus x is 2x, and then 2 minus 1 equal to 7. 2x equal to 7 plus 1, which is 8. X is 8 over 2, which is 4. So the answer is x equal to 4. And if you plug x equal to 4 back into this equation, is it okay? Does it fit? I'll leave the checking to you. Let's see, here's the answer key. Yes, indeed. X equal to 4 by the same process. Now, one more thing. What if this original problem had been written like this? Instead of this x minus 1 times x minus 2 form, it could have been written in expanded form like this. From here, can you factor this denominator to get to this? So that the LCD is x minus 1 times x minus 2. Can you get this to that? At this moment, there may be some students who are a little bit uncomfortable, but by the end of the first half of this course, at the very least, everybody should get comfortable with this kind of relatively simple factorization. Factors of 2 adding up to -3, you get -1 times -2, and that's how we get -1, -2 like that. A bit bigger font may be helpful. Factors of 2 adding up to middle coefficient -3. We need -1 times -2. Could be -2 times -1, but that's okay. Multiplication is commutative, so you can change the order. So if the original problem is given like this, you can still make it into that form and then go ahead with the same idea. A bit tricky here, but you should be able to do that. Maybe not right now, but at least by the end of the first half of the course, you have to get yourself back into the rhythm. Okay, so much for problem B. How about C? Well, we went through a couple of examples already, so stop the playback and do it on your own. Anybody got the answer yet? Not yet? Stop the playback and do it on your own. Okay, what do we have here? Multiply by the LCD, which is x minus 1. And that's pretty straightforward, isn't it? Multiply, oh, wrong key. And then multiply by x minus 1. Don't forget to multiply the same thing to the integer part. You have to distribute this to each term. Okay, do not break up the parentheses. X minus 1 over x minus 1, that simplifies into just 3x. And then the right hand side, x minus 1, this simplifies into 3. Okay, all right. Now, let's break up the parentheses. And then consequently, what do we have? 3x plus 2x, 5x equals 2, flipping this -2 to the other side, 3 plus 2, which is 5. 5x equals to 5, so x is equal to 5 over 5, which is 1. X is equal to 1. Looks like that's the solution. Is that what you all got? Let's see. So let me ask Mathematica to solve it. It failed to solve this equation, or maybe it did, it's just a solution does not exist. Oh, wait a minute. I got the solution x equals to 1, but this says, no, that's not a solution. What is going on here? What if you plug in x equals 1 to back into the original equation? What do you get? Does it work? No, it doesn't. If you plug in x equals to 1, we have 0 in denominator. So everything breaks down. Consequently, there is no solution. This kind of thing can happen when you have non-trivial denominator, or non-trivial square root, or all kind of complicated things, as a matter of fact, transcendental, all kind of things. For linear quadratic polynomials, okay, but anything more complicated, always you have to check. If it is difficult to track down, just check every single time. That'll help you.